Friends, welcome once again into VK Jan Sir ki MEP classes. In this particular module of lighting 1, we will discuss artificial illumination as compared to natural illumination. For centuries over, we have known that lighting is the concept related with one of the five human senses, that is sense of vision. It is a phenomena directly concerned with human comforts. The sight gives us most detailed information about our surroundings. The aim of artificial lighting is not only to supplement the daylight in case of poor external light or even to replace it completely, but also to produce comfort conditions for working of human eyes to reduce the possibility of accidents. Now at the bottom I have shown the color rendition known as rainbow, but here it is given in reverse order. Actually it is VIBGYO and R. Vivgior will work on this. Anything below red is known as infrared and has got heating effect, and anything beyond violet range is known as ultraviolet light. This perception of color is why human being. Let me explain the physical property of electromagnetic radiations. All electromagnetic radiations travel at a speed of 3 into 10 is power 8 meter per second, and nature of effect created by them varies according to their wavelengths. Something more about infrared radiations. Friends, EM radiations of wavelength more than 380 nanometer up to 790 nm are called infrared radiations. Now, something about ultraviolet radiations. Similarly, electromagnetic radiations of wavelength less than 380 nanometer down to 10 nanometer are called ultraviolet radiations, causing sunworm effect. What to some extent these radiations are detected by other creatures like nocturnal animals, due to which they respond to lighting effect earlier than human being during dawn and dusk hours. The terms ultra and infra are relative to frequency of radiation, which is just in reverse order of quantity of wavelength. The equation is V equal to F into A. Friends, in this particular representation, I have tried to show electromagnetic radiations, and these are the universal fact of transmission of energy waves having very broad frequency range and conversely wavelength as shown in side by figure. Now I am going to describe the entire electromagnetic range. The electromagnetic range of frequency 100 kilohertz and beyond up to 862 megahertz are known as radio transmissions, of which the first in order of frequency is long wave, then medium wave and short wave. We had been listening radio previously, and then VHF is equal to v, VHF, and UHF is utilized in TV. VHF is utilized in FM radio systems, and UHF is deployed in TV systems. So this column gives increasing frequencies, and this column gives uh, wavelength in reducing length. So anything happening here is conversed here. The other wavelengths of 900 to 1900 megahertz are utilized in mobile phones, and 250 megahertz, that means 2.5 gigahertz, is utilized in microwave oven. 2.5 gigahertz to 36 gigahertz are utilized for radar systems. Now we come into lighting range. This complete is lighting range. The lighting range having electromagnetic radiations having a range of 3 terahertz to 400 terahertz are known as infrared, and they have got a heating effect. Then comes the visible spectrum, which we know as a light. This is between 430 to 750 terahertz, or in terms of wavelength it is 780 to 380 nanometer. Then comes the ultraviolet range, which has a frequency of 7.5 into 10 raised power 14 to 3 into 10 raised power 16 hertz. These ultraviolet in terms of wavelength 10 nanometer to 380 nanometer in reverse order. Then comes X-ray and gamma rays. We are not concerned. Here I have shown the color spectrum of human eye known as VIVGEOR: violet, indigo, blue, green, orange, yellow, orange and red. Colors and their wavelengths are shown in this chart. Here wavelength, here frequency, and color effect created by them. Dear friend, now I am telling you the lighting accounts for 15% of our total energy generated in India, compared to 7 to 10% in developed nations. Superior lighting system design offers a 60% cost saving potential over conventional designs. Integrated system approach to lighting analysis necessary, involving daylighting, lamps, luminaires, controls, configuration, interior material and finishes. Friends, the figure here shows the cross-sectional detail of human eye, and you can very well understand there is a cornea, the white looking item, and at the back there is retina, and there are so many muscles known for lighting function, and this eye senses the light and convey it to brain through optic nerve. Friends, the figure at the top describes anatomy of eye. The first is cornea. This portion is known as pupil. This portion is known as iris, and this is the lens. At the back, you can see cornea, that is conveying information, light information to human mind. This is vitreous. Basically, the role of eye is to convert light into electrical signals called nerve impulses that the brain convert into images to our surroundings. The lens of the pupil, आँख की पुतली, focuses images onto the retina. The lens is made of many spherical layers like onion, जैसे प्याज के छिलके होते हैं, and is capable of changing its shape. Cornea, a clear covering on the front of your eye that focuses light entering the eye. Iris is the colored part of our eye that regulates the amount of light entering to our mind. It is a well-known fact that the pupil of human eye causes a reversing effect of any image that is then transmitted to mind. So it is at this level. mm, Suppose this is the object, then it is conceived through pupil, and uh, later on the effect that is created is just reverse of that and conveyed to the brain. Friends, now we will learn how colors are sensed by human eye by conical rods. In the next slide, I will show you the cones and rods. But let us see the eye's ability to perceive color is primarily due to presence of cones, which are specialized photoreceptors cells responsible for color vision. The cones are sensitive to different wavelengths of light, allowing the brain to interpret colors accurately. The three types of cone are there: long wavelength L cones. These cones are most sensitive to long wavelength of light, which appear red to human eye. These are concentrated in the red cone area of the retina. Second, medium wavelength M cones. These cones are sensitive to medium wavelength of light, which appear green. These are concentrated in green cone area of the retina. And the short wavelength S cones. These cones are sensitive to short wavelengths of light, which appear blue. These are concentrated in the blue cone area of retina. When light hits these cones, they convert the light energy into biochemical signals, which are then sent to brain for processing. The brain interprets these signals as colors based on wavelength of light that each cone type is sensitive to. This process allows us to see a wide spectrum of colors in our environment. Friends, this is the last of my this lecture. It shows illumination, different illumination level conceived by our eye. The nature has provided us a very wide range of susceptibility to lighting illumination level, illumination intensities. In summer midday, it is worth 1 lakh lux. Lux is the unit of illumination level or illuminance. In winter midday, it gets reduced to 10,000 lux. In night, full moonlight, it is just 0.2.5 lux, very low. During dawn and dusk, it gets reduced to 300 lux. Think of from 10,000 to 300 in winter and from 1 lakh to 300 lux in summer. Office general lighting, we need 300 to 800 lux. Friends, thanks for observing my lecture so coolly. Thanks once again.